Okay, today I'm doing a quick revision on the doctrine of energy. So this is important. Energy is present everywhere. It exists in various forms, and energy affects everything that occurs in our world as well as in our outer space. Because in a solar system, right? Yeah. So the sun produces tremendous energy, and this energy produced by the sun usually is converted to heat and light energy. That's why in the daytime you can see the brightness, just like here behind me, the Golden Gate Bridge, the rising sun. And also we can feel the heat. So Earth is the only planet in the solar system that supports life because there's sufficient temperature, oxygen, and also light, which is needed for photosynthesis. So very important, this key doctrine, you need to memorize this because this key doctrine will be used until secondary 4, at least. Even you pursue JC1, if you study physics, this law still applies. So energy cannot be created or destroyed, but be converted from one form to another. Okay, here's an example. If you inflate a balloon, because the balloon is made of elastic material, so the energy stored inside is actually the elastic potential energy. So what I want you to do is you put in the word elastic here to make it more specific. Then why is it elastic potential energy? It's very simple because the material is elastic. So the energy that is stored inside is hidden. So how do we release this energy? You will release the balloon, right? The air will escape from the hole. So that due to this Newton law of action and reaction, right? As the air escape here, okay, the elastic potential energy is converted into kinetic energy of the air. And as the air pushes backward, the balloon pushes forward. Action and reaction. So let's see in this example, we are asked to describe the energy conversion, right? When you release an inflated balloon, you should say the elastic potential energy of the balloon is converted to kinetic energy of the air, converted to kinetic energy of the balloon. So there are two arrows. Okay, this to this kinetic energy of air, and then to kinetic energy of balloon. So you can do that now by inserting this thing here. Okay, I write in short form, but in the exam, you write in full. So this is the energy conversion when you release an inflated balloon. Very simple example, right? Yeah. So just take note of this. So this is one good way to help students build confidence in writing energy conversion because this is related to their everyday lives. I'm sure during your younger days, you play with this, right? Yeah. So when you release the balloon will fly in a random manner. Okay. This energy conversion. Okay, very good. Let's proceed to the next part. Okay, kinetic energy is commonly tested in PSLE. Why? Because it occurs almost every day. You can see things in action. The kinetic energy is the energy of motion or movement, or moving car, wind, or flowing water. So you can see moving car. I use moving car because it's a solid. So when you see a solid moving, is kinetic energy. When I see wind, actually wind you can't see, right, but I can feel, right? So wind is made of a mixture of different gases, oxygen, nitrogen. So we can see kinetic energy in in the gaseous state, wind. And then water is in the liquid state. So the three state of matter, solid, liquid, and gaseous state, right? All can produce kinetic energy. Okay? Okay, next, any object that is not moving, we call it stationary, the scientific word. In English, we call it still. Okay? So normally I don't use the word still because still usually is talk about the water is stagnant or still. But for energy topic, we use this word stationary. Okay? So a stationary object does not have any kinetic energy. However, when you give it energy by pushing it or by exerting a push or pull, right, it can gain kinetic energy. So this word you need to highlight because this word gain and lose occurs very common in this topic. So gain means increase. Okay, when you increase the kinetic energy of a stationary object, you will set it into motion, means it's begin to move. So when it slow down, conversely, let's say something is moving, right? If we slow it down, it will lose kinetic energy. So in other words, the kinetic energy actually does not vanish into the thin air, but is converted, this keyword, converted to other forms of energy. So here I give you the hint, right? So if the surface gain heat means convert to heat energy. And then when you hear a breaking sound, sound energy. Okay, very good. Okay, next part is talk about how do we calculate kinetic energy. Okay, although this is not tested in PSLE, I put here, but it's good to know. So it depends on two factors, mass and speed. Okay? So the greater the mass, the higher is kinetic energy. Similarly, the greater the speed, the higher is kinetic energy. Okay, so this formula you will learn in secondary 1 and 2 is half mv squared. So it's 0.5 means half, right? Because I write in this manner, times mass, but it's in kilogram, and speed times speed. Okay, I will put it in simplified form because this word velocity is only introduced in set 1. For P6, is that treated as speed. Okay. So you can see here, actually, if you notice, there's a power of 2. That means if you increase the speed double, right, the kinetic energy will increase 4 times, which is illustrated in the following example here, which we did 2 weeks ago. So you can see here, these two balls, right, same mass, half times 2. So it's 2 kilograms. So that you substitute the 2 here. Okay, but the kinetic energy is being increased by 4 times because from 3 meters to 6 meters, right, per second is double the speed, right? So this is a good example to help students to see by increasing the speed 2 times, kinetic energy increase 4 times. So how does this apply in daily lives? Okay, one good example I use is the bullet firing from a police or military police gun is very small, maybe weighs about 10 grams. 10 grams is 0.01 kilo. If you use the formula, you got 10 divided by 1,000, right? So it's 0.01. But most of the bullets, the escape velocity means the time when it leaves the barrel is about 300 to 350 meters per second. So if you use 300, just use 300, right? 300 to the power of 2 is quite a big number. Okay? So the energy created by a moving bullet is quite big. You can calculate that yourself. So these are application of kinetic energy. Okay, what is a turbine? Yeah, it's in a power station. Okay, the turbine actually is something quite unique. When it's being driven either by moving air or moving steam or water, it rotates. As it rotates, it produces energy. So we can see that actually in dams, like the kinetic energy of running water can drive the turbines. Okay, as a turbine turns, it produces electrical energy. Okay. Next, sailboat make use of kinetic energy of wind to sail. Okay. And finally, windmills make use of kinetic energy. So this is a part on KE. And then later I'll move on to potential energy.